go. Hi, everyone. My name is Andrew Jester.
My name's Nate Fakuri.
I'm Hans Peterson.
And I'm Sydney Palmer.
And we are talking today about black box testing. Black box testing is an interesting concept. It's where the tester is only concerned about the input and output of the product. The tester doesn't know anything about the implementation, anything in the source code, or how the system is set up. Talking about this, it differs from white box testing, where the tester understands everything about the source code and the implementation of the system. And gray testing is similar to the two in the fact that the tester understands a little bit about the implementation, but not everything.
So now there's two main types of black box testing that we found. The first one is functional testing, and the second is non-functional testing. Now, functional testing deals mainly with the functionality or specifications of the application that's being designed. For example, what would be tested, like the smoke testing, sanity testing, integration testing, system testing, regression testing, or a user acceptance testing. On the other hand, there's non-functional testing that deals more with the quality and the performance of the application. So something like things like the usability, load, performance, compatibility, stress, and scalability testing. Now, there's also 7 different techniques that you can do black box testing. The first is equivalence partitioning. Then there's boundary value analysis, decision tables, state transition testing, error guessing, graph-based testing methods, and comparison testing. So the first one is equivalence partitioning. Now, equivalence partitioning is meant to be more for dealing just with inputs and measuring them and then comparing them to a different class of outcomes, or seeing what the similarity is between the outcomes. So in this case, in the example, someone would put in an age from 18 to 60, and depending on on the input, it would give an invalid, valid, or invalid, depending on its value. Then there's boundary value analysis, and then this technique focuses morely on the values at the different boundary levels, and knowing that most applications fail at some point at a given boundary, and that boundary is just near a limit where the behavior changes in the system. Then there's decision testing. This is a fairly straightforward testing method where, depending on what the program is or what set of rules are being implemented, there can be different conditions, and depending on that condition, some action will be initiated, or if that condition fails, then the second action will then take over. Then there's state transition testing. State transition testing deals with the different states in the system, and it shows the flow of how each state is going in the system. So in this example, we have the first attempt, second attempt, and third attempt. And depending on where the program goes, whether if it passes or not, it will then go to the home page. But if it fails, then it moves on to the next attempt, trying to get to the home page. And then if all three of them fail, then it goes straight to the account locked, and then nothing, and then it just ends. Then there's error guessing, and this technique, the tester uses the experience in the application or behavior and functionalities to guess the error-prone areas within the system. Now, there are some things to watch out for as a developer, and some common mistakes that we found is that developers may divide by zero, handling null values in text fields, accepting the submit button without any values, or file uploads without attachment files, or those files may exceed some size limit given by the program. And then we have comparison testing. Now this is just comparing two different systems and seeing how they compare against each other, and weighing the pros and cons against them. So if you have a similar operating system, for example, you would put them against each other and see which one performs better or does the tasks that are required possibly smoother, or see which one fails at a certain point, and then make note and possibly try and change that given operating system.
So the general upsides for black box testing, it's great for large systems because the tester and the developer are independent of each other. Then you can get a very balanced and unprejudiced testing. That way, the tester can be non-technical. They don't even have to know any part of the code. And it's also sometimes called acceptance testing because tests are done from an end user's point of view. This testing is very great for identifying vagueness and contradictions within the code and other defects. And when functional specifications are complete, test cases can then be designed. With downsides, of course, it's not as good for smaller systems. And if there aren't complete or clear functional specifications, then the test cases are very challenging to design. And if those test cases aren't designed around specific specifications, then it's difficult to identify tricky inputs, and it would be hard to find all possible inputs anyway with the limited time that you have. Another downside is that since the developer and the tester are independent of each other, there's a large chance of redundant testing. There are tests that the programmer may have already performed.
So there's several situations where this testing method especially is really effective. Working with large systems, since you don't need to know all the inner details of the system, all you need to know is the inputs and the outputs. This makes it shine, especially in large systems where there's a lot of complex coding and all these different in-depth things going on. It helps to give an ease of testing. Since testers don't need specific programming knowledge of the languages, or they don't need to know any of the inner workings of the system, you can have testers that just perform tests and they don't need to have any of those special abilities or knowledge. And since the test is performed from the user's perspective, it can help to give a better insight to how they view the system, like given inputs and outputs, like what they get for certain input and not knowing any of the stuff in between, just seeing it from their perspective really makes it effective in that circumstance.
And these are our resources. We hope you enjoyed our presentation.